This is the brief on Bernoulli's principle. So we're going to look at this from two angles, the strict math and a more intuitive visual one. This way, you get the complete picture of this fundamental law of how fluids move and conserve energy. Okay, first, the principle says that for an ideal fluid, and you can just think of that as a perfect frictionless fluid, the total energy along its path has to stay constant. This total is made up of three parts: the kinetic energy from its speed, the energy from its pressure, and the potential energy from its height. So what does that really mean? Well, second, it's just a fundamental statement of energy conservation. It means the total amount of energy a parcel of fluid has. It just never ever changes, no matter where it is on its path. And finally, because that total energy has to stay the same, you get these direct inverse trade-offs. Let's say the fluid moves into a narrow section and speeds up. Well, that increase in kinetic energy must be balanced by a drop in pressure. Or, if it moves to a higher elevation, gaining potential energy, then both its kinetic and pressure energy have to dip to compensate. This principle just clearly shows how a fluid's speed, pressure, and height are in a constant dance, trading places to keep the total energy balance true.